sine of n pi x over L. So this has to be equal to my given f of x, right? So you just got to, find the sine series a la section 10.4, is it? Or 3? 10-point question mark. I forget which section. The sine series section. I figure it's 10.3 or 10.4. Hey, I tell you what, let me just say sine series. Okay, there's known formulas for that. You find the sine series, and you just match up your coefficients from your sine series to the a sub n's. That's half the battle, right? But then we also need the partial y, partial t at x comma 0. What would that be equal to? Well, if you think about partial derivative with respect to time, you can ignore the a sub n terms, because when you differentiate this with respect to time, this becomes sine, right? When you plug in 0, that's gone. So the velocity, the derivative, the initial velocity term just involves the second part of this blank template. And so by the chain rule, we'll get the sum n equals 1 to infinity of like b sub n times L divided by n pi v cosine n pi, oh, I'm sorry. What's the cosine of blah, 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 blah times 0? Is 1, right? So let's not write that. So the cosine, I differentiate the sine, it brings out the L over n pi v. I plug in 0, it's still 1. Cosine of 0 is 1. And I'm still left with the sine of n pi x. Sine of n pi x over L. So what do you got to do? Well, this is equal to g of x, right? And so if you can write that g of x is equal to, let's say, the sum Cn sine of n pi x over L, what do? It tells you that the C sub n's are equal to b sub n times L divided by n pi v. See, this one's a little more, we saw we had we divide by 2 for the constant term in the last problem, right? Now the connection between the Fourier coefficients and the coefficients in the blank template, it's a little bit more subtle here, right? I actually have to solve for b sub n. My b sub n is what? It's, Cn n pi v divided by L. So the C sub n is something that you can calculate from the Fourier coefficient formula. Right? So now we got 2 Fourier expansions we had to do to solve a general problem. Usually the book is kind. It makes either f of x 0 or g of x 0. So you don't face the full onslaught of this problem. All right, so I will next, when we meet again, what is that? Tomorrow? Yeah. I will try to actually show you one of these at least with numbers in it. And I think what I'm going to do is I'm not going to cover the other thing we can do, which is really, really neat, is to look at a string that goes on and on and on, and then just at one endpoint, you can wiggle it up and down. And so think about this. If you have a string that stretches on and on and on, like long, long ways, and it's really, really tight, right? And if you just wiggle the string at one end a certain way, what happens is that exact propagation will go out, whatever shape you make. I mean, you could do like Morse code, right? D, 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 and it would just kind of propagate out, D, 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 so forth. And I actually show how to solve this problem with it doesn't have fixed endpoints. It actually has an endpoint which you're wiggling and out to infinity. And I show how to solve this problem with Laplace transforms for arbitrary wiggle function and show that it does exactly what I said. And it doesn't involve any of this. It's just Laplace transforms. It's really neat, but it's also really kind of like off the beaten track. I don't have enough in my library of examples to test on that. Like, it's the one good example I know of this technique. But I'd like you to watch it for your own, edification, enjoyment, whatever. You can watch it double speed. It's only going to be 12 minutes there. I think it's the first 24 minutes of the thing I'll link to for you guys. But anyway, with that, I will reduce the next class. We will be done. We have to be done tomorrow, at a little bit before, like maybe 12:15 I'll try to be done by I better be done by 1 tomorrow. I have been requested, my presence has been requested due to child dentistry. So, you know, I spent $3,000 in cavities last year. My children get cavities in between their teeth. Like they do brush, right? But in between somehow. I'm pretty sure it is the other thing we spend an inordinate amount of money on, which is fruit. That would be my guess. Because I don't really give them that much candy, despite their many requests. So I don't